Hi there. Big data sets are everywhere, so it's important to be able to analyze them efficiently. I'm particularly excited about Spark, so that's why we're going to talk about three things today. First, why you would like to use Spark. Then we're going to take a look at Spark streaming with some example use cases and a bit of theory. And finally, we'll end this with Twitter sentiment analysis, where we take an advantage of Spark and some particular packages in Python. So first, why would you like to use Spark? Well, if you have a big data set that you like to analyze, a naive approach would be to write imperative code, let's say in Python. So imagine you have millions of images and you'd like to do some processing, or you'd like to process them in some way. So your script would basically have to do all of these things sequentially. One way of solving this is to parallelize your code. So you have multiple cores doing parts of the job. But imagine if one computer is not enough, and you like to have multiple computers if data sets are big. And that's when it gets really tricky, because then you'll have to keep track of all of these subtasks, and in general you'll have this overhead. So ideally you like to use a platform such as Spark, because in Spark you don't tell how you like to achieve things, but you tell what you like to achieve. So when you write imperative code, you actually tell how you like to achieve things. But in Spark, you just tell what you like to achieve. And that's what makes it so powerful. You express your problem, and it will take care of spreading this, breaking this problem up into, so that it can run on multiple cores. And if you have multiple computers, it'll be able to help you with that. And you won't have to think about things like what happens if one computer breaks, or like what job do you have to rerun, and so on. So that's why Spark is so powerful. Now let's have a look at Spark streaming. Generally, data streams can be of two types. They can be static, in which case you could just use Spark, the normal Spark, batch processing, or you can have data streams where you have live data. So imagine you have a lot of thermometers spread across the country. And each of these thermometers sends you to some HQ, sends the temperature every minute. If you have several thermometers, it's not a big problem, but if you have multiple thermometers, it becomes really, really tricky, because you'll have a lot of data. And it might not be feasible to analyze this data afterwards. Usually, you can think about it, you get the stream coming in, and you'll then write it to some sort of archival storage. But if you like to do some analysis on this archival storage, it will usually take a lot of time. So you ideally like to analyze it continuously as it comes into this HQ. Here it's important to remember two things. That there are different types of questions that you can ask on data. So usually when you use a system such as Spark, the goal is that you like to ask some questions about data. And there are two different kinds of questions you can ask. You can ask, and they have, the names for these are ad hoc queries and standard queries. So ad hoc queries is basically where you don't know what you'd like to ask in advance, and you just ask something very specific about the data. And this is quite difficult, because you cannot, if you have large data streams, you basically have to go through the whole data stream and to be able to compute the answer. So that's why we have standard queries. And standard queries is where you can predict what kind of questions you might want to ask about this data. So imagine you have these thermometers spread across the country. You might want to know things like what's the maximum temperature recorded at a particular station or at a particular device, or maybe or a minimum, or some other metric that is useful to you. So in that case, since you know what you'd like to be, what you'd like to ask the system, then you can set this up when you actually get this data into your into Spark streaming. So you can and really cool thing about Spark streaming here is that you can also save state. So you can have a state which records the maximum temperature observed for either for all of them, for all of these thermometers, or for just one of them. And then the only thing you need to do is to check if the thermometer, once you get a new value, is this value bigger than the one you have recorded, and then you update accordingly. So that's very useful. So if you then next time when you want to ask this question, you already have the answer there. Whereas with ad hoc queries, it's going to be very difficult because you need to go through the entire data set. So basically, I would like to say that with Spark Streaming, it helps you quite a lot. I mean, it helps you with setting up these preparing standard queries, but when you're using the normal Spark on static data, then you're most likely you will be asking ad hoc queries on the data. But with live data streams, we assume that the data that we have saved in our archival storage is very, very hard to analyze afterwards. So we want to kind of predict the questions we want to ask about the data in advance. So, one particular use case here is to, as we mentioned, as we talked about, is the Spark. Is the having multiple thermometers sending temperature data to some HQ. The final point I'd like to talk about is how you can perform Twitter sentiment analysis using both Spark and some particular packages in Python. Here, I actually have the link provided below, so you can check this out and run this code. But basically, the idea is that we have one way. First of all, we need to retrieve our stream from Twitter. We create a local stream, and then we pass this stream to Spark Streaming. And Spark Streaming can then break this stream up into the keywords that we're interested in. And then, depending on what we would like to do, we can either just print out the current sentiment for specific tweets or for specific keywords, or we can use what we talked about previously. We can use this notion of or this ability of saving state, and maybe have keep a mean value of the sentiment seen so far for each of the keywords. So to sum up, Spark is a really useful framework when analyzing big data streams. You can either use it to analyze static data with this normal Spark, or you can analyze live data. And when you analyze live data, you have to be careful about, or you would like to know in advance what kind of questions you would like to ask about the data, because when you have, if you ask arbitrary queries, it's usually going to take quite a lot of time, because you have to go through the whole data again. And finally, we had a look at the example with Twitter and how you can perform sentiment analysis on Twitter, where you both combine Spark Streaming and natural language toolkit available in Python. Thank you.